guys, sorry the video was cut short. So my previous video, but I will be uploading sequentially. So like my previous video, we stopped from here, the integral of ln of x dx to be x multiplied by ln of x minus the integral of 1 multiplied by du. So my previous video, at first I wrote multiply by dv instead of du. So here we will cancel this with this, so we get the integral of 1. So let me just grab, and we get the integral of 1 x cancels with x, so it will be just the integral of 1 dx. And as I told you, this is just the same as multiplied to x with 0. So just add 1 to the power, divide by 1, so it's just x. So it's just with the integral of x. So our answer is x ln of x minus x plus a constant of integration. So this is your answer. So straight away, we'll be looking on the third example, the final one. The third example, the final example. I'll try to be quick to handle that. So this is the last example. These are definite integral. We are told to integrate tan inverse of x. So from our formula, LIATE, we'll have to choose our u with dv, keeping in mind the integration by parts formula. So LIATE. So this is a logarithmic function. There's no logarithmic here. Inverse trigonometry, it has started, so automatically this will be our u because inverse has started. So this will be our u. What will be our dv? Our dv will be anything remaining inside the integral. So we'll get our u to be tan inverse of x. So automatically we'll find our du because the formula requires du. So du is the derivative of that, the derivative of tan inverse of x. What's the derivative of tan inverse of x? The same as 1 over 1 plus x squared with respect to x, so dx. I'll be uploading a video on how to on the formulas of some of the derivatives, constant derivatives, some of the formulas on integration also to master for easy computations like these. We just have to write this instead of deriving all this. So our dv will be what remained inside the integral. So we removed tan inverse of x, so we remained with 1 dx. So we remained with 1 d of x. So this 1 d of x, so from our formula of integration by parts, we'll have to compute our v. So as I told you from the previous video, we know how to integrate 1 dx. It's just the same as x. I'll try to be quick. So let's replace all this information to the integration by parts formula. So the integration by parts formula says the integral of u multiplied by d of v is the same as u multiplied by v minus the integral of v multiplied by du. So just have to replace this integration equation with I. We get what's our u? Our u is tan inverse of x multiplied by our v, just x minus the integral of what's our v? X multiplied by our du, 1 over 1 plus x squared dx. So from here, this is correct, this is correct. We'll have to perform this. So we'll have to perform that. So how do you perform that? Let me clear here for space. I want to clear there. So let me just clear with this. Trying to be quick. So from here, we'll have to compute this. So let's compute this. How will you compute this? This will use trigonometry. We'll use u substitution or a w substitution. Because at first we said this to be u, so let's use w. So we'll use w substitution for this. So in case, so we use u substitution or w substitution to eliminate this x, the numerator. But in case x wasn't there, we could have used inverse trigonometry. I will be uploading some videos on how to deal with questions on inverse trigonometry, trigonometric substitution, their difference. So let's compute this. So this we use same as the integral of x divided by 1 plus x squared dx. So we'll have to choose our denominator expression to be u or w. So let's use w. So w equals to 1 plus x squared. So automatically we'll have to find our, okay? I've decided, let me just use u for easiness. Let me just use u. So let me just choose my expression to be u. So it's easy. So we'll find our du equals to differentiating our constant is 0. Differentiating this is just 2x with respect to x, so it will be d of x. Okay? So let's write this. So it will be the integral of x divided by the denominator we have expressed as u multiplied by what's dx. So with dx, we'll get it from here. So divided by 2x divided by 2x, this goes with this. So we'll remain with dx to be that. So we'll substitute this dx with this, so it will multiply by du over 2x. So from there, you can see our x goes in the numerator. So we'll be remaining with over 2, so it's just the same as a half. So my previous video we said any constant term inside the integral, get it outside, so we'll get a half the integral of 1 over u d of u. Okay, keep this in mind. Okay, let me just compute and just write from there. So we said yeah, let's tackle this. So usually say 1 over a variable or any other function, we are allowed to write ln of the absolute value of that function of the denominator only when, if you find the derivative of the denominator and it equals or it resembles the numerator, we are allowed to write ln, the natural logarithm of the absolute value of the denominator. So for this case, this is u. Differentiating u, these are variables, so automatically differentiating it will be 1. So 1 is the same as the value in the numerator. So we are allowed to write ln of x. So we just have to write a half. This a half multiplied by ln of this. So it will be ln of the absolute value of u, the denominator, plus a constant c. So this is our answer here. So from there, let me clear to write the final answer. So let me clear this. Let's write our final answer. Our final answer will be, so our final answer was from here. So let's write. So it will be I equals to x tangent inverse of x, okay, minus this, minus a half ln of the absolute value of u. What was our u? Our u was 1 plus x squared. 1 plus x squared. But for now, in this case, we won't write plus c. Why? We had the bounds. So we have already integrated that, so we'll have to replace with the bounds. Let's calculate now, placing with the bounds. So these are definite, so we'll get this expression, then we compute the bound. So from 0 to 1. So we'll just have to substitute 0 to this expression, 1 to this expression, then minus substituting 0 to the expression. So we'll get substituting x to be 1, so it will be 1 multiplied by tan inverse of 1, okay, minus a half multiplied by ln of 1 plus 1 squared is just 1. Oh, sorry, it will be x squared is 1 plus 1, 2, so it will be multiplied by ln of 2. I've already substituted the numerator, so that minus substituting now 0 to the expression, we'll get substituting 0 here, we'll get 0 multiplied by tan inverse of 0 multiplied by tan inverse of 0 minus a half multiplied by, placing 0 here, we'll get just 1, so multiplied by ln of 1. Okay, so let's clear this. 0 multiplied by anything is just 0, so it will be minus 0 minus, from here we have ln of 1. What's ln of 1? ln of 1 is just 0. We were told to compute ln of 1. It's just the same as 0. So a half multiplied by 0 is just 0. So all these expressions clears out. Okay, so all these expressions just 0 will be remaining with this. So it will be 1 multiplied by tan inverse of 1. What's tan inverse of 1? From the calculator, tan inverse of 1 is just 90. It's 90. Okay, so we'll write what's tan inverse of 1? Oh, tan inverse of 1 is 45, sorry, not 90, 45. 45. So we'll replace 1 multiplied by tan inverse of 1 in terms of radians, so it's just the same as 90. Tan inverse of 1 is the same as 45 degrees. But what is 45 degrees? We know 180 degrees is the same as pi. So what of 45 degrees? So it will be multiplied by pi divided by 180. Right? So 45 goes here 4 times. So it will be, our answer is pi over 4. So that's what we'll substitute there, pi over 4. So we'll get pi over 4. A quarter pi. A quarter pi, let me write. We'll just get a quarter pi. Quarter pi. Quarter pi minus a half ln of that. So this is your answer, but we can go further on by expressing this pi over 4 in terms of logarithmic functions. But just for this case, let's stop there. Just write that. So yeah. So this is your answer. Okay. I don't know if we can continue. We can just continue, convert it to a constant, and this is in radians. This is in logarithmic function. So you can as well as leave your answer here. So you can leave it from here, but for clarity, you can just continue. So expressing this pi over 4 in terms of logarithmic functions, we'll have ln, we substitute ln of e raised to pi over 4 minus a half ln of 2. Okay, so write using a common denominator. Placing a common denominator, we'll just have 2 ln of e to the pi of 4 divided by a common denominator 2 minus ln of 2, right? Writing by common denominator, that's normal LCM, finding the LCM, so you just divide by 1 equals to, so 2 multiplied by 2 here, yeah, that way. So expressing this, there's a rule in logarithmic function that allows us to take 2 and power it to this expression. So we'll take our 2 there, so just write e to the 4th as we square it. So this 2 we square it. So we'll get ln of e to the pi divided by 4. You square it. This 2, it will be a square that. So let me write this 2 here. So it will be squared minus ln of 2. All these expression divided by 2. This is 2. So from there we'll get, let me write here. But remember, you can just give an answer here. This is just an additional information, how to express into a constant logarithmic function so that the answers be. So yeah. So let me just continue. So we just continue from here. So here is what our answer says. So we get this. So how would you compute this? So this is just the same as 4th root of e to pi. So just write ln 4th root of e to the pi. Okay? And it's being raised to squared. It's being raised to 2 minus ln of 2. Okay? All these expressions divided by 2. Sure? So this is the 4th root of this. So we can just, this is squared, so it eliminates 1 square. So I was saying, this is the 4th root of e to the pi. 4th root of e to the pi. So this is just squared. So 1 squared goes with the 2 squared. So like it will be remaining with 1 square. So we'll write ln of now the square root of e to the pi, okay, minus ln of 2 divided by 2. So there's a formula again, there's a rule again that allows us to combine these 2 logarithms as one. So just write ln, so this is minus, so it's division, so it's the same as the square root of e to the pi divided by 2, okay? So we are clear that. So the whole expression divided by 2, that's your answer. Or this expression again, you can write it as ln to the e pi divided by 4, right? Then divided by 4 plus a constant c plus a constant c. So that's your answer. That's a final answer. So these are, we have cleared one technique of integration. We said integration by parts. So we have performed the 3 formulas. We have placed in 2 videos. So you might as well like check all the 3 formulas, or all the 3 examples. This is the final. Like, subscribe, and share. Thank you.